All right, guys, here we go. I think we're advanced enough now that we can start working on IVT, intermediate value theorem, don't worry, and continuity. You'll see it's not that bad. You guys ready? We're going to go right into it. Look at example number 1. It's a piecewise function. They call it that because it's in pieces, and I have letters missing. That K is a constant. That M is a constant. Cool? And all right, so here we go. It says, what happened? Oh, it's yours now. It says, consider the function g of x. To answer the questions below, what two limits must be equal for g of x to be continuous at x equals -2? All right, focus. So, what two limits must be equal? The limit from the left better be equal to the limit from the right at x equals -2. Do you guys see that? So the limit, I'll slow down. The limit as x approaches -2 from the left, which is kx squared plus m, better be equal to the limit as x approaches -2 from the right, which is 4x plus 1. So these two limits better be equal in order, not only must those two limits better be equal, but they also better equal the function at g of 2, at -2. Yes, miss. I'm sorry, what? Yeah. Does that make sense, guys? Or does that not make sense? Yeah, that's the only way they can be continuous. What two limits must be equal for g of x to be continuous at -2? This one better equal the one in the middle. And of course, at -2, it equals whatever, what's that, -8 plus 1, -7. So, are we cool? They just wanted to know what two limits.
Do we have to solve it already?
Eventually we will. What two limits must be equal for g of x to be continuous at x equals 3? Well, at x equals 3, the two limits that must be equal is limit, bless you, as x approaches 3 from the left, which would be the 4x plus 1, and that better equal 3 from the right, which is kx minus m. And of course, all that better just be equal to g of 3 as well. Are we okay? All right. Let's keep going. Now it says determine the values of m and k so that the function is continuous everywhere. All right, let's find that out. I kind of want to go to the top one. So a -2, ready guys? I know, and I'll write it right here, limit as x approaches -2 from the right of 4x plus 1. I know that that equals 4 times -2 plus 1, which equals -7. I know that much. Are we okay? I know that this one in the top better equal -7 at 4. So I'm going to write limit as x approaches -2 from the left of kx squared, was it plus 1 or plus m? Plus m equals, let's see, k times -4 squared plus m, which better equal -7. So I'm going to write equation number 1 over here. 16k plus m equals -7. Are we still okay? What's up? You're right, it's -2. I hate when I do that. -2 squared. Yeah, I would have had some funky number. 4k. Thank you, miss. Or else it would have been wrong 100%. Okay, 4k plus m equals -7. I think we're good. Yeah, or a simple one. Or maybe we're not have to. It's going to be a simple 2x2. Are we okay with that one? Let's do the other one. I changed the color, guys. So here we go. Limit. That's not changing the color. Limit as x approaches. Which one's the one that has the number? The one in the middle? 3 from the left. 3 from the left of 4x plus 1 equals 4 times 3 plus 1. 4 times 3 is 12, plus 1 is 13. Limit as x approaches 3 from the right, it's right there, of kx minus m equals k times 3 minus m, which better equal 13. So equation 2 is 3k minus m equals 13. Yes, miss. It has the minus m in the equation. Yes. Oh, it just happened. It just happened. Do we have any other questions, guys? All right, I have a system. I think everything is correct. I don't see any errors now. Do we see any errors? I make mistakes all the time as evidence. If I add these two expressions, I see that m's cancel out. So here we go. I'm adding them. M's cancel out. 4, 5, 6, 7. So I have 7k equals 13 plus a negative 7. What's that? So k equals 6/7. Now that I know that k equals 6/7, it doesn't matter what equation you use. You'll get the same value for m. I'm going to go to equation 2, and I'm going to go 3 times 6/7 minus m. Maybe I should have used the other one. It's okay. Equals 13. We'll use the other one just to verify that it's the same. 3 times 6, what's that? 6, 12, 18. 18 over 7 minus m equals 13. So I'm going to move that to that way, that to that way. 18 over 7 minus 13 equals m. What is that? 13 times 7? And then 18 minus 91? I was about to take out my calculator, but 73? You sure? All right, let me take out a calculator, guys. Here we go. What was it, 13? No wonder my calculator never came up. 13 times 7, 91. And what was the other number? 18 minus 91. Negative 73. I think you were right. Negative 73 over 7. Just for kicks, you don't have to write this down. I want to see if I would have gotten the same value for m using the top equation. You should. So there shouldn't be, let's see, 4 times 6/7 plus m equals negative 7. 4 times 6, 6, 12, 24. Excuse me. So m equals negative 7 minus 24 over 7. 49 minus 24. 49, 59, 69, 73. Negative 73 over 7. Is that the same thing we got? Yep, we got it. OMG. What? It's supposed to be happy face, but it's a Monday. How do we feel? All right, so let's go back. Don't worry, because look, we just did all this, and you're like, I have no idea what all this is. What did we just do? In order for this to be continuous, this one right here, the kx squared plus m, the parabola, the y value of the parabola better touch the y value of this linear line in the middle at negative 2. Does that make sense? Yeah. And then in order for it to be continuous at 3, the linear line of the 4x plus 1 better touch the y value of the kx minus m. Does that make sense? So supposedly these are the values that will make this piecewise function continuous. Cool? Any questions on that? All right. Let's see what else we got. Okay, so look at this question, guys. It says, and don't worry, we're going to relate it to limits in a little bit. It says, this is coming from UH. Given that f of x equals the square root of x plus 4 minus 3 all over x minus 5, define the function f of x at 5 so that it becomes continuous at 5. Not all of them are possible. This one is. This one has a hole at 5. It doesn't have a vertical asymptote. So pretty much what they're asking is, what is my limit as x approaches 5 of the square root of x plus 4 minus 3 over x minus 5? Now by now we should have some experience with how to tackle these. What would you do? Of which one? Good job. The square root of x plus 4 plus 3 over the square root of x plus 4 plus 3. Are we cool? When you do that, you get this. Limit as x approaches 5. Square root times square root, the square root goes away. X plus 4. And then negative 3 times the positive 3, that is negative 9. All over. And don't even bother distributing the bottom here. Are we good? What is 4 minus 9? And OMG, look at that. Limit as x approaches 5 of x minus 5 on the top over x minus 5 square root of x plus 4 plus 3. And there's a handful of you, about 3 of you, that keep doing this mistake. You do it correctly, bam, bam, but then you write this as a whole number and not a fraction. You write it as an integer. I'll give you back your paper so you guys can see. Now I can do direct substitution. 5 plus 4 is 9. What's the square root of 9? 3, and 3 plus 3? But a lot of you write that number. You write 6. Is that the limit? It's 1/6. And I know what you're thinking. You're probably like, one, I have no idea why you did what you did for this problem. All right, let me help you. Because this function has a limit at 5, this one I can make continuous if I write a piecewise function. How would you write a piecewise function for this to make it continuous? Like this. F of x equals, and then I write that, and then I write the expression square root of x plus 4 minus 3 over x minus 5, as long as x does not equal 5. So what you're telling the computer, or what you're telling people is, as long as x does not equal 5, use that. And then I'm going to change my color so you guys can see this. When x does equal 5, what do I want the output to be? So it can be continuous. What number? There it is. Now I just made it continuous. I call this f of x. It's in a piecewise. I have a point at 5, 1/6. So as long as x does not equal 5, use this expression. When x equals 5, use the 1/6. I plug in the hole. Done. It's continuous. Does that make sense, guys? Okay. Perfect. Ms. McLaren, you're okay? Oh, she's not here. Sorry, Montalongo, not McLaren. She was here, right? Sorry, Ms. Montalongo. Next time. You're here in spirit. All right. A lot of students think this is hard. You're going to see it's not that bad. It is called the intermediate value theorem. You guys ready? Read this and see if it makes sense to you. Did that make sense to you? Not even a little bit? Oh man, it's okay, it's okay. So here's what it's saying. You guys ready? If I were to tell you, so don't write this down, just listen. Does f of x equal 7? I like the number 7. Just listen right now. And I tell you f of 1 is 3, and I tell you f of 2 is 10. Somewhere between x equals 1 and x equals 2, and f is continuous. Does f of x equal 7? Yes. You have to cross, if the y value is 3 at 1 and the y value is 10 at 2, you have to cross 7 somewhere between 1 and 2 if it's continuous. How many times does it cross? You don't know. But how many times did you at least cross? At least one time. Does that make sense? That's all. That's all this says. That's all it says. Cool or not cool? And I know some of you are like, okay, how does this help? Well, here's an example. Let's read it together. You're driving to a Calculus Saturday session for your first mock exam, which happens to be your favorite class because you already know you're going to pass the AP exam. Yeah, go Cardinals, that's life. You look down at your speedometer, it says 55 miles per hour. Did you, at any given moment, before the instant you looked at your speedometer, travel exactly 52, 59? For sure, 100%, the intermediate value theorem says that you definitely hit 52 miles per hour at some moment. What about 59? Maybe, maybe not. The IVT does not help with that one. Maybe you did, maybe you didn't. And that's all the IVT is. Cool, right? And you want to see a really cool application of this in real life? This is true. I added this today. Let's skip example 4 just for a little bit. Look at example 5. This is a true story. This is IVT all over the place. I saw it on Facebook. Yeah, no, it was not like, when I saw it on Facebook, it was not in a math thing or anything. I saw that this Ada Felicia Basin Bridge, I can't pronounce that. It's in Louisiana. I saw that they were doing tickets. Look, let's read it. Let's read it. There's a new law that goes into effect this August. Well, when I typed this out in July, guys, so that's why it already went into effect. How do I pronounce that? Atchafalaya? Yeah, Google this, whatever. Basin Bridge. And this is a true story. Tell your parents about this one. Okay, anyways. The bridge is 18 miles long and is part of I-10. The new law allows use of cameras to support issuing a ticket based on how fast it takes a vehicle to get from one end of the bridge to the other end. Drivers who cross the bridge in less than 18 minutes would receive a speeding ticket in the mail. So look what's happening. So there's cameras. There's a camera in the beginning and there's a camera in the end. And it times you. It has a time stamp. Boom, you get at one end of the bridge, boom, it time stamp. 18 miles, how long is the bridge? 18 miles later, as you exit, another time stamp. How does it know whether you're speeding or not? Well, what's the speed limit? I don't know, it doesn't say here, but they tell you 18 minutes, so 18 miles and 18 minutes. Oh, that's easy to calculate. The speed limit is 60 miles per hour. Do you guys see that? And if you go faster, you're gonna beat this more than 18. You're gonna be faster than 18 minutes. So what I would do, I don't know, because I've never been to this bridge. But if there's a gas station, I am pulling over, because it doesn't matter how fast you go. If you stop at a gas station, you're gonna, the time. But anyways, isn't this cool? Look, here's calculus in action. When am I ever gonna use IVT? Well, here it is. Here's one. All right, so what's the speed limit? Speed limit is 60 mph. How'd you guys calculate that? How'd you guys calculate that so fast? You just saw 18 and it was like a mile a minute. Okay, fine. A mile a minute, 60 mph. I'll give you that one. You could have also done 18 miles divided by minutes and then turn minutes into hours. 18 miles divided by 18. It doesn't matter. It's the same. And in 60 minutes, there's 1 hour. There it is. See? 18 turns into 1, and you get 60 over minutes cancel out, and you get 60 mph. It doesn't matter. However you do it. 60 miles per hour. Oh, dimensional analysis? All right. Use intermediate value theorem to explain, is this law fair and just to all drivers? Why? I didn't put that. Make a 1 minute. So someone must. I remember talking to someone. You don't have to do that. Is it fair? You don't think it's fair? But we're trying to uphold the law. This is fair for everyone. No, I don't think there's a.
I thought you thought.
I think the law officers like let you go 5 over, but I don't think that's like a law. I mean, if you go over, you go over.
When did they report that it should take 18 minutes?
Well, it's 18 miles long and the speed limit's 60 miles. The speed limit is 60 miles per hour. So,
Are we talking about traffic?
yeah, like it should take you 18 minutes or longer to cross. If you cross in 15, if you cross in 10 minutes, you're driving way fast. All right. Think about that question, guys. Here we go. Let's go back to example 4. All right, sorry, guys. Here we go. Yeah, and they do. That's okay. Look, I'm all about. I am a fast driver, but here's the big but, guys. Big but. Make sure. Please do not drive like a maniac in a neighborhood. If you're in the middle of nowhere, you're in West Texas, and there's not a car to be found for miles and miles and miles, go as fast as you want. I mean, as long as it's safe, you know? If you have a car that's like 50 years old, do not floor it. I mean, you know, it's breaking down and everything. Make sure that it's safe for you, your vehicle, and the people that are riding with you. All right. Yeah, then no. Tell them no. All right, here we go. Example 4. Can the IVT be used to show that there is a solution for the equation f of x equals 0 on the interval 1 to 2 if, bless you, f of x equals this expression, given an explanation, and y? Okay, so to do this, guys, just do this. It's simple. F of 1. All you care about is whether the number is positive or negative. So f of 1 equals 3 times 1 cubed minus 5 times 1 squared plus 1 minus 3. Let's see what that is. 3 minus 5 plus 1 minus 3. 3 minus 5 is negative 2, plus 1 is negative 1, minus 3 is negative 4. Well, you guys okay? Here we go. F of 2. They're telling us it's continuous. Do they? Oh no, well we know. It's a function. It's a continuous function. 3 times 2 cubed minus 5 times 2 squared plus 2 minus 3. Let's see. 3 times 2 cubed is 8 minus 5 times 2 squared is 4 plus 2 minus 3. I'm just going to put minus 1. So let's see. 3 times 8. 8, 16, 24 minus 20 minus 1. 24 minus 20 is 4 minus 1 is 3. Okay. I'm going to go slow. Bless you. So here's what we know. F of 1 is negative. That's how you say negative. F of 2 is positive. Did I cross the x-axis at least once between x equals 1 and x equals 2? Yes. So you're going to say, here's what you write. I'm going to put it in blue. F of x equals 0 somewhere for some x, and then in parentheses I'm going to put between 1 less than x less than 2, close it, since f of 1 is less than 0 and f of 2 is greater than 0, comma, now put period. And I'm going to write, since there was a sign change, comma, f of x must be 0 for x is between 1 and 2. Let me read that, see if it makes perfect sense. f of x equals 0 for some x, and in parentheses I put for x is between 1 and 2, since f of 1 is less than 0 and f of 2 is greater than 0. Since there was a sign change, f of x must be 0 for an x between 1 and 2. Done. Does that make sense, guys? Or no? Okay. They're not looking for an essay, so do not write, a conclusion and introduction and 3 parts, whatever. Yes, miss. The what? Huh? Oh, I don't want to put equal to because I want a sign change, so I just want to say it's negative or it's positive. You could have also said positive or negative. You could have used those words, but I'm just trying to show you that this is how you say negative and this is how you say positive. You don't have to use them. But because you're taking a math test, you want to use math language. You know what I mean? And then what did I answer your question? Maybe I didn't. Say it again. Oh, when would we use less than or equal to? Or greater than or equal to? Well, if I want to know, see, we're not there yet. If I want to know where a function is strictly increasing, I need my instantaneous rate of change or my slopes to always be positive. And as long as you don't go negative, the function will always be increasing. So there you could say, as long as my instantaneous rate of change slopes are greater than or equal to 0, because they can be 0, it just means you're not going down. But we want, you know what I mean? We're not there yet. We're not there yet where we can use the less than equal to, greater than equal to. Did I answer your question this time? Okay. All right. Make sure that we understand example 5, guys. I think that's a good question. Ask it to your parents. See if they like it or not. Example 6. You guys ready? No? Oh, that was a good one, miss. Here we go. Give the value a and b for the function to be continuous at 1 and at 6. So if I want to be continuous at 1, I know that a times 1 minus b better be equal to 15 times 1. Now notice I'm not using limit notation. Maybe it's sloppy math, but I think we understand what we mean there. Yes or no? All right. And what about at x equals 6? What x equals 6? 15 times 6 better be equal to b times 6 squared minus a. Does that make sense? So here's equation number 1. Everyone know where I got those two statements from? All right, equation number 1. A minus b better equal 15. Equation number 2. What's 15 times 6? 15, 30, 60, 70, 80, 90? 90. 90 equals 36b minus a. How do we feel? And now we're going to solve. I think I'm going to take equation 2 and I'm going to write it like this, guys. A equals 36b minus 90. Can I do that? And guess what I'm going to do with that one? Plug it in. Equation number 1. 15 times 6. Would it be what? That just moves this to the left and that to the right. A equals 36b minus 90. I don't see any errors, at least not right now. All right. So A minus, I said I was going to substitute A. 36b minus 90 minus b equals 15. So let's see, 36b minus b, that's 35b. And I'm going to move that 90 to the right. So 35b equals 90 plus 15. Is that 105? And divided by 35, am I going to get a pretty number? I should. B equals 35 and 35 is 70. 70 over 35 is 105. There it is. B equals 3. We got a pretty number. If you get something nasty, it's probably wrong. Now that I got B is 3, you can just plug that in right there. Right there. A equals 36 times 3 minus 90. 36 times 3, let's see, 30, 60, 90, and then add 18. That 108? 108 minus 90? 18. There you go. Oh, you did set some of the equations?
No, I did the top equation for me.
Oh. Oh, yeah. That's way simpler. I don't know why. I guess I got focused on that one. Cool or not cool? Sorry, guys. I didn't notice. A minus B equals 15. You could have just plugged in B. B is 18. Sorry for making it tougher. All right. Example 7 and example 8 are not even calculus. So remember, Cervera, how we said, like in math, we want to say like something's always positive or something's always negative? So check it out. Because we're getting to sign changes in a little bit. So example 7, this is not calculus. It just says, solve the inequality for x given that x minus 5 squared times 28 minus 4x is greater than 0. So what this means, I want the expression on the left to always be positive. I want x values that will make sure that everything here on the left will always be positive. Cool? So I know that x minus 5, when I square it, this will always be positive. I don't have to worry about that. Do you guys see that? I do got to worry about the 28 minus 4x. Equal that to 0. This is sometimes called critical number. So 28 equals 4x. Divide by 4, divide by 4. X equals, what's that? 4, 8, 12, 16, 20, 24, 28. Is that 7? That's my critical number, guys. So I'm going to draw a number line. And I'm just going to put 7. Yes, miss. Yeah. Actually, also put number 5 as well. Yes, go ahead. Yeah, that's why I put the 5 in there. No, there is no holes. It's continuous. You can't equal 5 because you want it to be positive, and at 5 it's 0. Say it again. Yeah, open circle, not in the domain. All right, so Abdul Karim was saying that can you be 5? It doesn't say equal. Do you see an equal sign in the bottom? It doesn't say equal, so 5 would also be a critical number. Chavez, how'd you get to 5? Simple. X minus 5, what makes that 0? 5. So I put 5 into my railroad track or number line. All I care about is the sign. I don't care about the number. I care about whether it's positive or negative. If I plug in a 0, so I already know the x minus 5 squared is always positive. So let's go to the 28 minus 4x. 4 times 0 is 0. 28, that's a positive. So I put a plus symbol. If I plug in an x equals 6, 4 times 6 is 24. 28 minus 24, positive. If I plug in a 10, 4 times 10 is 40. 28 minus 40, that's a negative. So negative. All right, what's my answer? Negative infinity all the way until I hit 5. Can you be 5? No, because it doesn't have the equal sign. Union 5 all the way to 7. Well, don't worry, we're going to do another problem. Huh? No, 7's not a bracket. At 7, it's 0. Valencia, you all right? You guys ready for another one? Oh, this one has vertical asymptotes, guys. Do you guys feel like screaming? It's watermelon time! I'll stop. I need to have watermelon and start serving it. What time is it? Just throw watermelon. I'll stop, guys. I'm gonna have to erase all that. All right, here we go. Sorry, I was trying to wake you guys up because you guys are falling asleep. Vertical asymptote. X equals 2, x equals 8. Write those down. Those are critical numbers. And I have one more critical number. What will give me a 0 in the numerator? What will give me a 0? 5. So I'll put this here. 2x minus 10 equals 0. 2x equals 10. X equals 5. These are all critical numbers. I drew my railroad track. I'm going to go ahead and put 2, 5, and 8. All I care about is positive or negative. What do they want it to be? Negative. I want the expression to be negative because it says less than 0. Are we okay? All right. I'm going to plug in a number to the left of 2. Give me any number to the left of 2. What's the easiest one? 1 or 0. Whatever you think is easier. I think 0 is easier, so I'm going to plug in a 0. If I plug in a 0 in the top, I get a negative, negative 10. If I plug in a 0 in the bottom, 0 minus 2 is negative. 0 minus 8 is negative. Negative times a negative is a positive. So I have a negative divided by a positive, which is negative. Put a negative symbol. Pick a number between 2 and 5. 3. 2 times 3 is 6. 6 minus 10 is negative. Put that in your head. If I choose I already said 3. 3 minus 2 is positive. 3 minus 8 is negative. Positive times a negative is a negative. So I have a negative in the top, negative in the bottom. What's that? Positive. Put a plus. Give me a number between 5 and 8. 7. 2 times 7 is 14. Minus 10, that's a positive. In the bottom, 7 minus 2, that's a positive. 7 minus 8, that's a negative. Positive times the negative is a negative. I have a positive in the top, a negative in the bottom, so that's going to give me negative. And then one more, a number bigger than 8, like 10. 2 times 10 is 20. 20 minus 10 is a positive. In the bottom, 10 minus 2 is positive. 10 minus 8 is positive. Positive divided by positive is a...
Mr. Chavez?
Yes, ma'am.
Please post attendance.
Yes, ma'am, I will.
Thank you.
So here we go. Here we go. Where am I negative? There's the last one. Let's start from the left to the right. Leftmost number. Negative infinity all the way till you get to 2. Union from número 5 hasta el Chavo del Ocho. That might be too old for you guys. My grandma used to see it all the time. I don't know if it's still around or not. And that's it. Do you guys remember Chavo del Ocho? Is it still around? No, right? Because my grandma used to watch that all the time. It's like a Mexican stuff. It's funny. It's like a guy that never grew up. He had like a cap with a little fan. I remember very vaguely. I don't remember a lot. Yeah. I remember sitting down with my grandma. I had no idea what was going on, but I remember like it was entertaining. I was like he would do dumb stuff. It was cool. All right, how do we feel? Was today's lesson super extreme? No. So let me pass out the activity, guys. I want you guys to do the activity together in groups.